CATIA v5 saving a step file. So this will be the case study assembly. As you can see over here, we have multiple colors for various faces and parts. And now, in order to save a file as a step file, we need to go up to File, Save As. And over here within the Save As type, we have the possibility to change this to a step file. But as we can see over here, we don't have additional settings. So if I'm just going to click Save like this, CATIA will start and convert those. But in order to define the type of step file, we need to go up to Tools. Afterwards, we're going to go within Options. And over here, under the General Compatibility, we will locate the step file. So usually by default, you're going to be all the way over here. Onto the left side, you need to select and swap between individual file formats. And for step, this will be all the way in the back. And over here, we have the application protocol for export. As you can see, I currently have this set for ISO 214. By default, CATIA will have this set to 203 ISO. We can also go with the newer version, like 242 over here. And let's see, the main difference is that the first protocol, 203, will only export geometry. And to better highlight this, we're going to check the following link over here. So initially, what are step files? We see the file format, so both step and just STP files, so without the E over here. And this is a standard file format for exchange product data. And this is the, let's say, the neutral 3D file format. And this is used by all the CAD programs, such as we see the first one, CATIA, Creo, SolidWorks, NX, Inventor, and others. So there's also Fusion and so on. And also FreeCAD if you are into open source software. We see over here what will be the difference between the protocol 203, 214, and 242. So why is step file format important? This is important because you can use, for example, CATIA, and you can save your design and have it exported to a different software, like for example over here SolidWorks, and you're still gonna retain all of that geometry. And not only geometry, you're also gonna retain some additional annotation information regarding the drawing. And this is why it's important to use neutral CAD format such as step, because they will be available to any user that makes use of a CAD software. So it's not just within the software that it was designed. And let's take a look over here. So this will be the application protocol 203 over here. And let's take a look at the features. So we're going to have the products as mechanical parts and assemblies. We're also going to have data for configuration control applied to design phases. And most importantly, over here, we can also export geometrical data as wireframes, surface model, facets, also manifold surface, and solid bodies. So this will not only take, let's say, the geometry, for example, that we have a sketch and we extruded that. We are also going to be able to retain individual sketches. For example, as I have over here, the wireframe of that circle. That will also be transferred. If you're going to take a look at the newest version, so not really the newest, this will be the second, AP214. We see this protocol. This will also export colors, and this is really important. For example, for this case study, it's important to have that color retained within other software. And to show you that, I also have the step file over here. So we see this will be that. And we're going to see that all of those have been retained. So we have the wireframe, we have the coloring over here. So over here, we're going to see this will be the part, and we're going to have the final product over here in green. But we're also going to have all of those coloring. So if I will go over here within a sketch, within a dynamic sectioning, we're going to see that. So over here we have a little bit of overlapping between that pin and the part. But other than that, we're gonna have all of those exported over here. So the coloring and the layout. So the features of this file format, as we can see over here, will be everything that was added within the previous file format, but also we're gonna have colors and layers, also annotation, associated geometry, and elements regarding geometrical dimensioning and tolerance with graphical presentation over here. We're gonna see over here also a construction history in 3D. This is not really the case for every CAD software. For example, over here, this has been saved as 214, but we don't have the history for that. So if I will just expand the part, this will be just a solid body, and we're gonna have some sketches over here as a geometrical set. But we are not gonna have the construction history in 3D within all of those CAD software. So some CAD solutions offer that, but CATIA doesn't. And we can also see over here a kinematic structure. And this will be the latest protocol over here, so 242. And this will merge step files to create a single standard for model-based 3D engineering. And we see that all the features from the other two previous file formats will be added, but also we're going to have some new elements, such as we see over here 3D kinematic assembly, 3D piping, some elements regarding mechatronics, but again, within the current build of CATIA V5, not all of these will be, let's say, usable and accessible. So what is the best file format? I highly recommend to use the latest, but mainly the 214 is more than sufficient for most case studies, because usually you're just going to export solid bodies, surfaces, wireframe, and you're going to want to have the color also exported, and in some cases the annotations, because those are the most important elements. Okay, so I hope you find this video useful. I will position a similar video over here on the left side and the subscribe button to the right. So that's it. Thanks for watching.